Let's solve this equation with the quadratic formula. X squared minus 3 halves equals 3x. This equation has a fraction in it, so one of our constants is going to be a fraction. Now, we can certainly use the quadratic formula with fractions, with whole numbers, with negative numbers, and with decimal values. But sometimes it's easier not to, especially if you're calculating some things by hand. So let's go ahead and clear this fraction. Remember, the trick for clearing is to multiply both sides of the equation, or all terms, by the common denominator. In this case, that would be 2 because there is only one denominator. 2x squared is just 2x squared. 2 times 3 halves would be minus 3 equals 2 times 3x would be 6x. So you just have to multiply all terms by the common denominator. Now we don't have 0 on one side, so let's move that 6x over. Remember to write in descending order. So we're going to get 2x squared minus 6x minus 3 equals 0. Now that we have 0 on one side, pick out a, which would be 2 because it's the coefficient of x squared. B would be negative 6, the coefficient of x. And c would be negative 3. Now, plugging in these values into the quadratic formula, we'll get x equals negative 6, because we want negative b, plus or minus the square root of b squared, or negative 6 squared, minus 4 times a, which is 2, c, which is negative 3, and that is all over 2 times a. Calculating, I get x is equal to 6 plus or minus the square root of 36 plus, because when we subtract a negative we get a plus, 4 times 2 is 8 times 3 is 24, all over 2 times 2 is 4. Continuing to simplify, x equals 6 plus or minus the square root of 60 over 4. Now the square root of 60 is not a perfect square, but it does have a factor that's a perfect square. I can rewrite 60 as plus or minus the square root of 60 is 4 times 15. Now that square root of 4 will simplify as 2. So I get 6 plus or minus 2 times the square root of 15 over 4. Now sometimes when you are able to simplify the square root, you can simplify the numbers that are remaining in the fraction. The way to check is to remember that this 4 is a common denominator. So if I want to simplify something with the 4, I need to make sure it simplifies both with the first term as well as with the second term. In this case, 6, 2, and 4 are all even numbers, so I can take a 2 into each one. 2 going into 4 is 2, into 6 is 3, and 2 into itself is 1. So I'm going to be left with a simplified fraction of x equals 3 plus or minus 1 times the square root of 15 is just the square root of 15 all over 2. That's a simplified result for my fraction, and my two solutions would be 3 plus the square root of 15 over 2 and 3 minus the square root of 15 over 2. So those are the exact values without using a calculator. If I want to use a calculator, I can round these off and get 3.44 rounded to the second decimal point and negative 0.44. So these would be the approximate solutions. Often approximate solutions are great when you're working with applications. Exact values are really nice when you're just solving an abstract problem. So two different ways to express your solution set. Don't forget to check by plugging those values back into the original equation. Always go back to the original one. And it's really easy, as we did in the last example, to use the approximate values. I'll leave that for you. Let's solve this equation with the quadratic formula. 3x squared equals 4x minus 6. We have the x squared term on one side, and we have the x term and the constant on the other. We could move the x squared term over to the right side, but right now it's positive, so it's actually better to keep it positive. Usually I find that people make less mistakes with the quadratic formula if a is positive. It doesn't matter if b and c are positive or negative. It just seems like people tend to screw up a little bit more when their a is negative. So I like to keep a positive or make it positive if it isn't. So I'm going to move these other two terms over. So I'm going to have 3x squared, so I'm keeping the x squared term positive, minus 4x and positive 6 equals 0. Picking out your a, b, and c, a is 3, b is negative 4, c is 6. Plugging that into the quadratic formula, x is equal to, well, negative b, or 4, I should say. This is negative b, so that's negative 4, plus or minus the square root of b squared, so negative 4 squared, minus 4 times a times c, so that would be 4 times 3 times 6, all over 2 times a, which is 3. Simplifying, we have negative 4, which is positive 4, plus or minus the square root of 16 minus 4 times 3 is 12 times 6 is 72, all over 6. X is equal to 4 plus or minus the square root of a negative 56, all divided by 6. Now, that negative 56 means we're dealing with non-real solutions, imaginary solutions. The trick for simplifying this is to remember that the square root of negative 1 is just I, so I'm going to pull out the I and leave in the 56. 56 will simplify because it has a perfect square of 4 inside it. So I have 4 plus or minus I times the square root of 4 times, that would be 14, all over 6. Now the square root of 4 is really just 2, so I'm going to have x equals 4 plus or minus I times 2 times the square root of 14, all over 6. Now remember what I said in the last example. You can simplify what we have here left in the fraction as long as it will go into, there's a factor that will go into all 3 of these terms. These are all even, so I can take a 2 into each one of them. A 2 into 4 would be 2, into 6 would be 3, into 2 would be 1. So I get a simplified answer or solutions where x is equal to 2 plus or minus I times the square root of 14 over 3. So I have 2 solutions there. Now I want to point out one thing about imaginary answers, and that is that the typical way that we see answers written in mathematics is to split these into 2 fractions. This 3 is a common denominator, so we can write this as 2/3 plus or minus, and then often they'll pull the I outside of the fraction and write the square root of 14 over 3i on the outside of the fraction. This is how you tend to see imaginary complex solutions written. I'm okay either one of these 2 ways, but if you happen to be reading through the book, you may see it expressed this way. So writing out the solutions, we would have 2 solutions, one of 2/3 plus the square root of 14 over 3i, and the other one would be 2/3 minus the square root of 14 over 3i. 2 complex solutions. So let's use Desmos to check those solutions. Our first equation was x squared minus 3/2 equals 3x. I mentioned that you could check them by just plugging those values in with your calculator, but let's see what Desmos shows us. So let's graph the left-hand side, y equals x squared minus 3/2. So there's the left-hand side graphed, and then y equals 3x on the right. And we're looking for the solutions is where the 2 graphs cross. So I have one intersection at negative 0.44 if I round for the x value, and the other's intersection at 3.436 for an x value. Notice again, if we round that, 3.44 and negative 0.44. Those are exactly the same thing we got when we solved the equation and rounded off our answers. Now let's graph the other equation where we got the imaginary solutions. So 3x squared, oops, I forgot my y. Y equals 3x squared on one side, and y equals 4x minus 6 on the other side. And if you look closely here, we have the parabola totally not touching the line. So what we have here are no real solutions, because when we graph in the xy plane, we're graphing real solutions. So what this is showing you is you have no real solutions because the graphs are never going to meet. The parabola is always going to be above the line, or the left side of the equation will always be above the right side of the equation in the graph. So there's no real solutions, and that's what we saw. We saw imaginary solutions. We could see from the graph in Desmos that this equation had no real solutions. But when we want to check to see if these imaginary solutions are correct, we can't really see it on the graph, so we really have to check by hand. So we're going to put these solutions into this equation. So 3 times, I'll take the first imaginary solution, 2 plus I times the square root of 14 over 3 quantity squared equals 4 times 2 plus I times the square root of 14 over 3 minus 6. Now I want to calculate both sides. Now on the first side, I'm going to square before I multiply by 3. To square that fraction, it's easy to square the denominator. 3 squared is 9. To square the numerator, I have to really carefully FOIL out this. 2 plus I times the square root of 14 squared. So foiling that out, I'm going to get 2 times 2, or 4. And then the outside term would be 2 times I times the square root of 14, which would be plus 2I square root of 14. And then the inside term would be the same thing, 2I times the square root of 14. And I need a little more room here, so I'm going to give myself a little bit more room with the parentheses. I'm going to have I square root of 14 times itself. Now, I times itself is I squared, and then square root of 14 times the square root of 14 actually just becomes 14. So I end up with this statement. Now I can multiply by the 3. The 3 is really 3 over 1. The 3 will go into itself once and into 9 3 times. And let's simplify that numerator. We've got 4 plus, well, 2I square root of 14 plus 2I square root of 14 is really 4I square root of 14. And then I have plus I squared times 14. A little reminder, I squared is equal to -1 because I is equal to the square root of -1. So when you square I, or square the square root of -1, you get back to what was underneath, which is -1. So I squared times 14 is really -14. And that's over 3. I can collect the 14 and the 4 and the -14 to get -10 plus 4I square root of 14 over 3. Let's check the other side. Now on the other side, I have the multiplication first. So the 4 distributes through the numerator, so I get 8 plus 4I times the square root of 14 all over 3 minus 6. Now to add the fraction and the whole number, I need to think about getting a common denominator. So I need to multiply the whole number of 6 over 1 by 3 in top and bottom to build to a common denominator. So I have 8 plus 4I square root of 14 over 3 minus 18 over 3. When I then add the numerators, 8 minus 18 is -10 plus 4I square root of 14 over 3. That is exactly the same thing on both sides. It's not really simple to do, but it is doable. If we were to go back and check the second solution, the only thing that would change is this negative here. And that is actually easy to see that it will come out the same. That's not going to change the first and last terms when I FOIL. It's going to change the middle terms. So instead of getting positive 4I square root of 14, I get a negative 4I square root of 14. So I'm going to get -10 minus 4I square root of 14. And on the right side, it changes this to negative 4I square root of 14, negative, and negative. And again, you see the same thing on both sides. So it turns out that most of the work is working with the first check, and then the second check is usually pretty easy to confirm.